So this is a lecture in which I will be defining mathematically what current is, and then I will be defining mathematically what drift velocity is, and also the equation of the current and current density in form of drift velocity. And next I will define mathematically the Ohm's law. So this is what we will cover in this lecture, and going to the first topic. So coming to the first topic, what you'll need to know is that you'll need to know that the current is given by charge per unit time, and the unit of current is ampere, also coulomb per second when you're considering this in SI units. So this is a very specifically very clear case, and when you are having like we saw that the electron is having a charge of 1.6 into 10 raised to minus 19 coulomb, and you needed something like 6.25 into 10 raised to 20 electrons to get 1 coulomb of charge. So if we are considering a conductor which is a wire, I'm connecting this wire to simply something like a battery, which is a 5-volt battery, if I can say. Then there will be some resistance of this wire. So again, resistance is opposition to flow of current, and this is connected here. So there will be a current I flowing. So taking this full conductor cross section in a simpler way, so if I take this conductor cross section in a simpler way, then I can say that if there is a time period of my observation is delta t or t simply, then there will be, and the area, if I say that it's A of this cross section of this conductor, then I can say that if I'm saying that 1 coulomb of charge is passing per 1 second of time, which was my time of observation, then I can say that the current I equal to 1 divided by 1 equal to 1 ampere. So this is how I am defining my current. So the current is the flow of the electrons. So the electrons will flow in this direction and in this direction. So essentially the charge which you are considering is the flow of electrons. If you consider, then the electrons will be flowing in this way, it will be entering from here. So the flow of the electrons or the flow of the charge per unit time is known as the electric current. So this is a mathematical definition, this is a universal definition of the electric current in the field of electrical engineering, and this is how you define it, and this is the unit of electric current. And again, considering the next case of defining the, so we found that current I can be given by Q by T, again having the unit of ampere, and there is a current density which is current per unit area, that is ampere per meter square. So again, considering that cross section, so the area was A, and if the current flowing in this direction was I, so the current per unit area will be known as a current density, which can be given by something known as J. So that was how we defined the current and current density. Again, going through the other which common phenomena which we are going to see in this lecture is something like a drift velocity. So considering an atom will have a nucleus which will be consisting of a proton and neutron, and there will be electron. If there is a simple case of hydrogen atom, there will be 2 electrons. So if you are considering any metal like copper, it's again taking the same cross section, there will be millions of atoms here, and taking each atom, the electrons will have some amount of electrons which will be loosely bounded to the atom. So if there is some form of external force, like there is a temperature rise or some amount of heating happening, the atoms will vibrate on its own axis, and some electron might become free from this orbit. So whenever it becomes free, it might have some random motion, that it might strike with the other atoms and it might again strike with other atoms. So again there is no net work being done here, because the net motion of this electron can be considered zero. But if you are applying some amount of electric field in this direction, uh, then that will cause the electrons to move. Or you are connecting this to a battery, causing a current to flow in this direction, and the motion of the electron in this direction, then there will be some amount of net work done. And anyway, considering that an electron started at a place like A and it moved in this way and it reached a place B, so you can say that the electron covered a total amount of distance which can be given by L, and if you are having that time t, then the drift velocity can be given by as distance divided by time, that is L divided by t. So this is how you are defining the drift speed or drift velocity of the atom or the electrons. Coming to the Ohm's law. So the Ohm's law is mathematically defined as a relationship. It can be remembered easily in form of this, and it can be said that V is equal to IR, or V by I is always R. So if you are having a circuit, which circuit is a closed connection. So taking a simple example where you are connected a light bulb, this is my light bulb and I'm connected this to a battery, and the resistance of the total circuit including the light bulb is something like 2 ohm, and I'm having a battery of 5 volt, and again I have connected something like an ammeter here. So there is an ammeter here which will measure my current. So if this is my variable source, so what I find is that while I am taking 5 volt, so I find that my current using this equation is V divided by R. So it's I equal to 5 divided by 2, which is equal to 2.5. So I'm simply giving it as 2.5 here. And again, this is my I1 first observation. Again, I am having a second observation where I'm at 5 divided by, or I'm having increasing the voltage to 10. So in that case, the current will increase to 5 ampere. So that is a 5 ampere here, and this is my 10 volt which I have put, and I'm plotting a graph of this. So this is the intersection point. Again, this will be my intersection point, not considering to the scale, but simply considering, and whatever is my slope of this graph is known as my resistance, and it's found that the slope will be same, or it will be same for any of resistive circuit. So this phenomena is known as a direct relationship between voltage and current in any circuit, and it said that voltage and the current will always have some kind of a direct relationship, and which is known by a constant. The slope, as you can say, a constant resistance. So the unit of resistance of any circuit is ohm, and the resistance of the circuit will depend on multiple factors. or any conductor will depend on multiple factors. It is found that mathematically resistance is directly proportional to, or resistance is equal to rho L by A. So if I am having a conductor and I want to find the resistance of this conductor, then this is the area of the conductor and this is the length of the conductor, and the resistivity will be different for different material, and it will be a function of temperature usually. So for higher temperature the resistivity will be high, the temperature will be high, the resistivity will be high. So the temperature will be high, the resistivity will be low for some materials. So as the temperature increases, the resistance will decrease. So that's how you are defining the resistance using the resistivity, length and area. Again, the inverse of resistance is known as a conductance, and the unit of resistance is ohms, while at the same time the unit of resistance, resistivity or conductance is mho. So the resistance is the ease with which electrons can flow through a conductor. So the ease with which electrons can flow is known as resistance, and the difficulty or the difficulty with which is sorry for that so the difficulty which or the opposition which the electrons face while they are flowing from one point to the other in the conductor is known as the resistance, while the conductance is the ease with which the electrons can flow. So that's how you are defining the resistance and conductance of a circuit. So what we saw in this lecture was we defined the current mathematically as Q divided by time and the unit as ampere. Then we define the current density as I divided by A and the unit as ampere per meter square. And then we saw the Ohm's law, which can be easily remembered as this way. So V in any circuit, voltage and the current will have a direct relationship given by VIR. This is known as the Ohm's law, and we found out the resistance of the circuit. Resistance, a new quantity, and the unit of resistance will be always ohms, and the resistance can be given as V divided by I, which is also volt per ampere, and the inverse of resistance is known as conductance, which can be given as the unit mho. So and the resistance is given by the equation rho L by A, which is, and rho was the conductivity. So that's what we have learned. So if you see the unit of conductivity, it could be ohm meter square per meter, so you can say that it's ohm meter, and the inverse of conductivity or inverse of, so this was resistivity, sorry, and the inverse of resistivity is something known as conductivity. So this is what we have learned in this lecture, and these are the universal equations in the field of electrical engineering. So these are some of the universal equations, and we have considered the SI unit system while defining the units like amperes, meter, etc. So that's all. If you like this video, please do subscribe.